Well, good morning, everyone, or good afternoon, depending on where you're at. My name is Tim Raines. I'm AWS's leader for security and compliance in EMEA, so the Europe, Middle East, and Africa. Welcome to today's webinar. I'm joined today by Mr. Enrico Masse, who is a security specialist solution architect with AWS. Enrico is going to be answering questions that attendees type into the chat window during today's webinar. And hopefully at the end of this, we'll have some time to answer questions and have a short Q&A session. But by all means, as we go through the content during today's session, if you have questions, please type them into the chat window and Enrico will answer some of them and maybe we'll keep some for the end and we'll approach it like that. All right, so with that, we'll get started today. Thank you very much for joining us. We really appreciate your time. This session is actually very popular. I've actually been talking to a lot of people around EMEA for the last couple of months with this content. Big part of my job is to go and talk to customers, specifically public sector customers in Europe, Middle East, and Africa, and talk to them about cloud, about security, about compliance, what their requirements are. And I learn a lot from those conversations. And in having those conversations, I come across some myths about cloud computing, and I come across, a lot of customers that are embracing opportunity around cloud. So in today's session, I'm kind of distilling that down into some popular myths that I hear and some popular opportunities to share with you. All right, so let's get started. So we're going to go over three myths that I hear, probably the most popular myths I hear from customers in across EMEA, and then we'll talk about a couple of opportunities that I'm excited about, and I know many of the customers that I meet are excited about it as well. And so we'll go through each one of these in turn. All right, so the first myth is that attacks are getting more advanced. And this is a narrative that it changes all the time out in the industry. The reason why I think I hear this myth a lot is because it's a lot of the attacks that we see in the industry over the last 10, 15 years have been reported, all of them have been reported as the most advanced attack we've ever seen. It's a nation state. They're using, tactics that are very hard to defend against, and, they're getting more advanced all the time. And this isn't really true. From my perspective, all of the attacks that we're seeing are essentially old wine in new bottles. And as we walk through this, the content here, I'll explain why. All right, so first thing is, I'm not saying that there isn't a lot of advanced malware out there. There absolutely is. In my former life, working for the world's largest software manufacturer, I was involved in creating threat intelligence reports for almost a decade, and so I've studied all of thousands and thousands of pages of threat intel over the past decade, and I know a lot about malware and commodity malware as well as advanced malware. The malware families that I have listed here and the specific pieces of malware, in my opinion, these are among the most advanced pieces of malware in the history of the world. And you can see I'm kind of giving you a chronology here. Obviously, a lot of these antivirus labs at this point are processing millions of unique pieces of malware every week. So there's lots of commodity malware out there. But in terms of advanced malware, it's actually kind of rare that you see malware that is, that has characteristics that distinguish themselves from the rest of the families, because families of malware can contain thousands, sometimes even millions of variants. And so these ones here that I've listed here are the ones that I think are most noteworthy in the last, let's say, 10, 12 years. So Zeus or Zbot, depending on which antivirus vendor you use, is definitely makes the list because it was a very successful, and probably still is, a very successful crimeware piece of malware that enables people to essentially defraud victims. And so it started off, as banking crimeware and expanded, so that attackers could attack all sorts of industries where there are transactions happening. So it was very successful. And it was very prevalent. Most of the antivirus labs around the world were removing this, from places all over the world, and so very successful piece of malware. Conficker, if you've been in the industry, for 10 years, you've encountered Conficker, whether you realize it or not. It's still out there at some levels on the internet, but Conficker essentially was novel at the time because it was really the first worm that traveled around the internet. The initial variant of it, the initial version of that piece of malware used some unpatched vulnerabilities to try to spread, and those vulnerabilities were thankfully patched by most organizations. Microsoft offered the patch a few weeks before this worm came out. And then because it didn't really get traction, the bad guys actually released variants very quickly after that. And it would take advantage of those unpatched vulnerabilities if they weren't patched. It would use a hard-coded list of passwords, things like password 1 2 3 4 test, all of the favorites that IT people like to use, and it would also use social engineering. So it would use what we call auto run feature abuse in the Windows operating system to try to spread. But it was very novel at the time because it used DNS to as a command and control channel in a way that you hadn't seen a worm do that before. Stuxnet, obviously this is a very advanced piece of malware at the time, the most advanced piece of malware that we'd seen. The US government actually came out and essentially admitted that they engineered this piece of malware, and it was designed to essentially attack nuclear enrichment facilities in Iran. And this is a well-documented story, but they used 2-3 zero-day vulnerabilities in Stuxnet along with some social engineering for it to do what it did. Of course, it had some unintended consequences because besides successfully attacking that facility, it also actually spread outside of Iran into the Western world, and you can still see volumes of Stuxnet out on the public internet. Flame, for my money, Flame is still the most advanced piece of malware probably in the history of the world. And I say that because of all of the resources the attackers that put this together had to have. Essentially, Flame enabled a man in the middle of an attack and required some very, very sophisticated engineering. So there's a few things that happened here. One of them was someone had to break into 2 different facilities of 2 different companies in 2 different countries and physically steal digital certificates from those facilities so that they could successfully do this man in the middle attack. In addition, they had to do a very sophisticated crypto collision attack, which you have to have a background in mathematics and encryption to pull something like that off. And then they had to have some knowledge of the Windows operating system and find zero-day vulnerabilities that nobody knew about that enabled them to sign code as if they were Microsoft. And so this was a very, very sophisticated attack. And that set the bar super, super high. Dooku 2.0, this is extremely sophisticated as well. This one, they call this the son or the grandson of Stuxnet, and that's because they believe that it has some of the same characteristics, and therefore they're attributing it back to the same people that perhaps designed and implemented Stuxnet. This essentially successfully attacked a couple of different hotels, technology inside those hotels, and during a time when those hotels were being used for very sensitive nuclear proliferation discussions amongst governments. And so a very advanced piece of malware. And then Triton is a newer one. This one successfully attacked a power facility in the Middle East and was able to take it offline for a period of time. So there's definitely advanced malware out there. But as we'll see, these pieces of malware, all of them, use the same tactics to attack their targets. And for the most part, malware is post compromise tools. They automate a lot of the steps attackers like to take once they get into an environment. Some of these, like Conficker, successfully attacked and were responsible for initial compromises. But as we'll see, all of these pieces of malware actually use the same 5 ways to initially compromise organizations. Okay, so next, there's also definitely a lot of really large compromises that have gone on over time. And as you can see from this list here, I've scrub the names to protect the victims in this case, but there's lots of massive data breaches that have happened over the last 10 years. This is sort of the top 25 list. And what's noteworthy about this is when you take a look at the top 25 breaches of all time and you kind of average out the number of records that were exposed during those breaches, it's almost 300 million records per breach. Which is more than the population of every country in the world individually, except for the largest 3. So breaches have been very large. The other thing is, it's not like the breaches happened a decade ago and things seem to be getting better and organizations seem to be getting better at protecting data, because 8 out of these 10 breaches of the top 10 breaches of all time happened in the last 2 years. And 4 of the top 10 breaches of all time happened just last year in 2018. And so there's definitely a trend here of super large data breaches that have been happening in recent history, as opposed to something that happened years ago and things seem to be getting better. But I still will tell you that in every one of these cases, every single one of these organizations got breached. One of the 5 ways that organizations get initially breached. And I'll go over those 5 ways here in a moment. In addition to all of those big breaches, there's security organizations, so organizations whose core competency is data protection, that have also been breached over time. And these organizations, I'm not calling them out, they actually shared their stories and they shared how they got breached so that we could protect, the rest of us, all the other organizations in the world could learn with what happened with them and how the attackers attacked them and so on. And so these folks here have deep expertise in data protection and defending against advanced adversaries and so on. But yet the advanced adversaries were able to attack these particular organizations. And so that says something about the state of the internet, is that even really, really good security companies and organizations can get compromised. But as we'll see, even these organizations, all of them in fact got compromised, one of the 5 ways that organizations get initially compromised. All right. The other thing is that confuses a lot of these headlines that we read about compromises and breaches and so on, is that they oftentimes confuse attackers' motivations with the tactics that they use to attack. And so what I have listed here is sort of the usual suspects when it comes to motivations. Years ago, notoriety was the big one, right? So we've all heard about the hackers in the basements that wanted to prove that they're smarter than the big technology companies and so on. And certainly notoriety is still a motivation today. In the 2007 timeframe, we saw malware, particularly backdoor Trojans, just exploded at that time to support a relatively new motive, which was profit. And of course, that continues to be a motive to this day and will continue well into the future. Military espionage has been around since militaries have existed. So militaries are trying to figure out what capabilities other militaries have and steal those capabilities if they're able to do that. This is nothing new. Economic espionage, you see this being played out in the press all the time, with countries blaming other countries for stealing intellectual property and giving it to companies or organizations within their country to unlevel the playing field when it comes to economics. Hacktivism, when organizations don't like the politics or the economics of other organizations, they'll attack with that in mind. And then something that we've seen sort of play out since the 2016 elections around meddling in elections and so on is essentially foreign policy goals that are being forwarded via information warfare and culture manipulation. And so we're seeing social networks and so on being used to try to influence elections in Western world. Okay, and there's lots of other motivations. But very often when you'll read an article about an attack, a successful compromise, um, they'll say that it's very advanced, and they're asserting it's advanced because it's a nation state. And it's very, very difficult to do strong attribution on an attack. If you can't figure out who is attacking, then you can't really understand what their motivation is. And so the internet, which is based on IPv4, a 50-year-old protocol, it makes it very difficult to do strong attribution. Organizations that can do that typically have more capability than simply looking at network traffic and trying to decide where it's coming from and where it's going. Usually have boots on the ground, and they actually have sources and methods to get information on who's attacking who. But for the most part, doing attribution and truly understanding what the attacker's motivations are is super hard. So keep that in mind when you read articles about attacks. Okay, so what I'm asserting here and what I've seen over the last 15, 20 years of doing data protection is that there's really 5 ways that organizations get initially compromised. After they get initially compromised, there's all sorts of advanced things that go on. I mean, you saw the list of that advanced malware doing all sorts of things, from damaging industrial control systems and uranium enriching systems, centrifuges, turning technology inside hotel rooms into microphones, all sorts of things that happen after the compromise. But the initial compromise, how they get into the environment in the first place, hasn't changed for a long, long time. There are really only 5 ways that organizations get compromised. And I say this again from studying threat intel, thousands of pages of threat intel that we published in a former life for over a decade. And so the first one is unpatched vulnerabilities. Many of those advanced pieces of malware that I talked about earlier rely on unpatched vulnerabilities, specifically 0 days, which is an unpatched vulnerability that a vendor has not provided a patch for yet. And so many unpatched vulnerabilities out there. Every 6 months, you're sort of looking that the trend is essentially between 2,500 and 7,000 unpatched vulnerabilities across the entire industry. So there's lots of vulnerabilities, and this is what keeps vulnerability management teams busy all the time. So they're constantly scanning their infrastructures, constantly looking for unpatched vulnerabilities and testing and deploying patches. So this is a constant work, and the bad guys take advantage of the time it takes to do the testing and deployment of vulnerability patches, and the time that they have knowledge of it. And so that gap between the time that the vulnerability becomes publicly known and the time it gets patched is critical. And that's a big source of compromises to this day. Security misconfigurations is very similar because vulnerability management programs typically manage this as well. The same types of scanners that you use for vulnerabilities are also capable of scanning for security misconfigurations. So security misconfigurations are things like default settings that aren't secure, hard-coded passwords, or passwords that are common from the factory. They're all set the same way and they never get changed. Common configurations that administrators make mistakes on, or over time inside of infrastructures, you actually deploy something in a very thoughtful way and it's actually secure. And over time, because of different things happen to it, whether it's administrators or upgrades or whatever, it starts to stray from the baseline into a less secure posture. And so that's what a security misconfiguration is. And there's plenty of examples of organizations getting compromised due to security misconfigurations. Weak leaked stolen passwords. There's massive lists on the internet of weak leaked and stolen passwords that the bad guys sell or trade for things that they value. One of the major issues that's been in the industry for decades now is the fact that people will use their passwords across services. So whatever password they're using for one service, they'll use the same password in multiple services. So for instance, if they use it at work, they might use it also at their bank, they might use it at e-commerce sites, they might use it for email and so on. And then when one of those sites gets compromised and that password gets leaked, the bad guys that get it have automation and scripts and so on that will try that password and the credentials profiles at every single website on the internet, looking for people that are actually reusing passwords across services like that. So this can be a very tough situation. It's definitely been a challenge in the industry for decades. Multi-factor authentication, MFA, is making a dent in this and is making a difference, as well as some of the advanced algorithms they have in place now for determining where someone is authenticating from, the relative trustworthiness of the device they're authenticating from, and the strength of the credential that they're using. You can make some intelligent decisions about whether to put friction into the authentication process using things like MFA and biometrics and so on, that help this problem around weak leaked stolen passwords. But this will continue to be an issue as long as we're using passwords in the industry. Social engineering by volume is the largest source of compromise. It always has been. And so from a malware perspective, the category of malware called Trojans, which is, something that says it's one thing, but it's really another, is really just tricking the user into making, very poor trust decisions. It's usually having them install something. For instance, they want to watch a video, but it says they're missing the video codec in order to watch it. Just install it. We have it right here. And when you install it, you're installing the world's worst Trojan backdoor that then will download more malware or unpack malware from itself, install remote control software, enlist you in a botnet, and then allow the bad guys to use your system for all sorts of project work like spamming and phishing attacks and storing illicit material and so on. So social engineering is going to continue to be an issue because tricking people into making poor decisions is as old as the hills, right? And so this is, something that is going to persist into the future. And an insider threat is, there's essentially two categories of this. One of them is sort of the hapless administrator that makes mistakes because instead of using automation that's tested and repeatable, they're doing things in a manual way that lead to misconfigurations and weak leak stolen passwords, going and surfing the internet from a system that should never be used for that. And if it's not fully patched and they run into a drive-by download site, they get owned, very quickly. And so administrators, what we're trying to do is take people out of the IT business by offering them the ability to automate things and get people out of making those types of decisions. The other category of insider threat is malicious insiders. So insiders that have privileged access to resources that decide to use that privileged access in a way that allows them to steal data or to damage systems or to, all sorts of different motivations as we talked about. So those are the 5 ways that organizations get initially compromised. And as I mentioned, this is really old wine in new bottles. We talk about this stuff as if things are getting more advanced, but frankly, as I mentioned, all of that malware, all of those compromises, regardless of what their motivation is, they're actually initially compromising environments using one of these 5 ways. So this means that if your security strategy that your organization is using doesn't address these 5 things at a minimum, it's incomplete and there's risk there. So my advice is revisit whatever your cybersecurity strategy is and make sure that at a minimum, you're addressing these 5 ways that organizations get initially compromised. Now, I've written a blog on this topic and I include some of the ways that AWS services enable you to mitigate these 5 ways that organizations get initially compromised. So you can read about that in depth here up on our public sector blog. All right, so it's time for a survey question. And we're going to pop open a poll here.
Okay, so what threat is your organization most worried about? 40% of people were most worried about advanced malware, and 48% most worried about insider threat. The other 3 answers are with smaller percentages there.
Okay, great. Well, thank you for running that down for us. That's very interesting. So almost half of the respondents are saying that insider threat is a big risk that they're worried about. That's very interesting, and it's also very consistent with what we hear from customers when they first contemplate moving from on-premise into the cloud. They want to learn all about the mitigations that mitigate insider threat in that scenario. And so AWS has actually been developed from the ground up with that in mind, knowing that our customers, the first question they're going to have is how do we mitigate insider threat? And so I'll talk a little bit about those technologies and capabilities here in the next section. All right, thanks, Jess, and thanks everyone for answering the survey question. All right, so let's move on to myth number 2. I hear this one a lot when I go and talk to customers that are first contemplating moving into the cloud. One of the first conversations they want to have is about security and compliance. And that's very reasonable. I mean, you want to know about whether your cloud provider or your service provider that you're considering can meet your internal standards, can meet your compliance obligations, regulations, all of the things, all the requirements you have. Super important to make sure that if you're moving into a cloud service, that provider can actually meet your requirements, and in some cases, hopefully exceed them. So those conversations are super important. One of the things, that we've noticed is at least in my conversations with customers, is many of them have this underlying assumption that a public cloud service is sort of the same as what their managed service provider has been giving to them, or maybe very similar or the same as what they've been doing on premise, but just at a larger scale, and that's why they're called hyperscale cloud providers. But that's really not a very accurate view of the world, because the way AWS is developed is very different from what you've been doing on premise, and very different from what your managed service providers have been providing to you. And so I'll give you a little bit of insight into why I say this. So before I can jump into that, have to give you a little bit of a primer in the way that AWS is architected, just so you can understand how some of these underlying services work and so on. So the first thing is, I usually get the question is like, how many data centers do you have? Where are they located? What does the network look like between them, and so on. And so to understand this in AWS parlance, we have a data center, right? And then there's a group of data centers, or a cluster of data centers is what we call an availability zone. And so this idea of availability zone is essentially the same as a cluster of data centers. And a cluster of availability zones is what we call a region. And so you can very quickly start doing some basic math in your head, and you think, wow, when AWS comes into a location to build a region, they're not just building one data center and then 50 or 100 or 200 miles away, they're building a second data center and calling that a region. They're actually coming in and building a cluster of data centers called an availability zone, and they're building a cluster of availability zones, and that's what they call a region. So this is very different from what other cloud vendors offer. For the most part. And so just keep this in the back of your mind, because this is actually important, an important architecture to keep in mind when it comes to things like availability, fault tolerance, and so on, and security, as we'll see. Now, these regions that I'm talking about, which are clusters of availability zones, are all over the world, and this gives you an idea of where they are. The numbers inside the yellow dots are the number of availability zones inside those regions. And so you can see there's also a number of new regions coming soon. And so Bahrain, Cape Town, Hong Kong, and Milan all have regions coming to them in the near future. And the latest region that opened up actually is here in EMEA, is in Stockholm, Sweden, or in the Sweden region. And that region opened up just in December here. And so we're getting, lots and lots of interest across the Nordics with that particular region. There's also a service that we call CloudFront, which is essentially a content distribution network. So a content distribution network, or a CDN, is essentially a type of service that will bring content closer to the people that consume it. So let's say today I'm in Berlin. Let's say I'm a Berlin-based company, and I've got customers in Asia coming to get content from me. Now, if they're coming from, someplace like Australia, they're coming all the way from the other side of the world to get content that I have sitting here in Germany. If I cache that content closer to them, like if I actually put it right in Australia, that will speed up the customer's experience. It will make it more reliable. There's all sorts of benefits that a CDN will bring. In this case, including denial of service attack prevention or protection, and web application firewall, which prevents all sorts of attacks on web applications, so SQL injection and malformed types of requests and so on. And this network is actually spread out. You can see 160 points of presence around the world in 65 cities. And so this provides some really good DDoS protection. If you're looking at DDoS protection, this can be very helpful. There's a couple different flavors of it. It's a service that we call Shield. So there's Shield Standard, which everybody gets that just becomes a member of AWS and starts using AWS services. And then if you want your, for instance, if you have a security operations center and you want them to communicate with AWS when a DDoS attack is hitting you, you can buy the Shield Advanced service, which will also include the WAF service for free and a bunch of other benefits. All right, so here in EMEA, where I'm assuming most of our attendees for today's webinar are based because of the time zone, there's, you can see the 5 different regions that we have here and the number of availability zones in each one of those regions. As I mentioned, Stockholm is the newest one. The very first one was Ireland, and then you can see London, Frankfurt, and Paris. And then below you can see all of the different cities in this region where we have points of presence for the CDN CloudFront service that I mentioned. All right, so why am I telling you all this about this infrastructure? What does this have to do with on-premises being more secure than the cloud, right? Why is this a myth? Well, the reality is when you come into AWS, you're actually delegating responsibility for all of the stuff that I just talked about. So the security and the compliance of the data centers and the services that run in those data centers. So you're delegating the gates and the guards and the lights and the cameras and the cages and the fences and all of that physical security around all of those data centers. And you have the ability to use services in an AZ, in a region. You decide when your data moves, right? So if you put data in a region, that data never moves unless you move it from that region. And that's super important because there's a lot of companies or organizations that have their own standards, their own rules. Sometimes there's regulation that says you cannot move this data outside of this location. And so AWS won't move your data. You're the only one that will move your data because you own that data. So you can, with confidence, you can go into an AWS region, and if you never want that data to move, it's not going to move. You do have the option to actually have a multi-region deployment though, so that you're mitigating the risk. If an entire region went down, every data center and every AZ went down for some reason, let's say there's a massive power outage and an entire country went down, your business and your data would continue to be available because it's in another completely different region. That's an option. It's not a requirement. So you have options. Now you've delegated all of this stuff, all of the stuff that has taken time, money, and effort to manage from a security perspective, compliance programs, audit, all of the stuff that you had to do around these physical premises has now been delegated to AWS. It's what we call our shared responsibility model. And now you can focus more on the services and the security around those services and working on automation and the technical debt that's been on your to-do list for probably a decade. And lots of organizations, this is initially hard to get your head around, is how does this work? It's like, yeah, instead of spending all your time working on stuff that you've delegated essentially to your cloud service provider, now you can use that same talent and that same labor force that you have, that technical talent and all that tribal knowledge to focus on things that matter. And so you can see here on this slide some of the stuff I'm listing, the difference between on-premise and AWS. But for security people, I think that most of the time when I first talk to a CISO about a chief information security officer about the cloud, the thing on this list that typically is an epiphany for them when they see it for the first time is that central control plane. It's what we call the API-driven cloud. Now, why is that important? Well, the API is a very, very powerful thing if you haven't looked into this before. But essentially everything that you do, every interaction you have with AWS goes through a set of APIs. Now, whether you're interacting with AWS through the AWS console that you log into in your web browser, or you use the command line interface. So a lot of people like to write scripts or like to run commands right from the command line instead of using the console. The command line commands also go through a set of APIs. And then if you write an application using an SDK and a compiler linker and all of that good stuff, those obviously go through API as well. And so from a security perspective, if every interaction with the cloud has to go through that set of APIs, if we just watch those APIs for indicators of compromise, for bad behavior, for unexpected behavior, for anomalies, we can identify things very quickly and we can actually take action on them in very like near real time. And so the API becomes a perfect choke point for visibility and control that literally, I mean, it's baked into the cloud and into AWS by default. And there's nothing like that on premise, nothing that gives you complete visibility and complete control across all the systems that you have deployed in your environment. Because you've got to remember in AWS, it's infrastructure as code, right? You don't actually implement things manually. You actually write code in services like CloudFormation, which allow you to get inventories almost instantaneously using services like AWS Config. You know exactly what's in your environment. You know what it should look like because you've implemented it using code. It's been codified, and you can see very quickly if it's strayed from that standard configuration that you've implemented, and you can actually automatically pull it back into configuration or just blow it away or quarantine it and do forensics on it. There are all sorts of choices that you have that you can do because the API enables all of that. It enables you to see things in near real time and take action on it using things like Lambda, which is serverless computing. You don't have to provision servers to sit there and watch Lambda, or sorry, sit there and watch the API calls. So a service called CloudTrail is essentially a logging service that logs every single API call that happens inside your account. And you can see who did what to what, when, from what IP address, and then you can use servers like Lambda to continually look at that and inspect it for indicators of compromise and bad behavior and so on. And then decide, do you just want alerts? Do you actually want to take action automatically? What do you want to do with it? So that is a game changer for security people. And there's a whole bunch of other things that we do inside of AWS that will differentiate it from what you've been doing on premises all these years and what your managed service providers do. So I'll just point you to this one white paper, but essentially what this is explaining is how AWS uses a combination of VPC for our virtual private cloud, which allows you to do, very, very granular control over network access to resources inside of AWS, virtualization. There's some virtualization technologies that you should just look up on the internet. There's some good videos from our reInvent conference on, for instance, the Nitro hypervisor that will show you how AWS has been evolving the hypervisor and how it's reducing the attack surface area in the hypervisor by offloading functions like administration and networking to hardware instead of having that all implemented inside the hypervisor or the operating system. And then encryption and key management allow you to actually do ubiquitous encryption. So whether data is at rest in a whole bunch of different services or data is in transit, key management is, absolutely critical in the cloud world. And what you're trying to do here is understand where your data and the keys that you are used to encrypt and decrypt it see the light of day, minimize that and understand the risk around that. So this approach of using, networking, very innovative virtualization, encryption and key management, and then things like bare metal systems give you the type of control that you need to ensure that you have physical logical separation of duties. And this is how we actually ensure that nobody in our data centers that has physical access to servers can ever get logical access to applications or data. It's just not possible with the technology that we've implemented here. So you can read more about this at this logical separation handbook that I've listed here. All right, so it's time for another survey question, Jess. All right, thanks for that recap, Jess. So that's very interesting. And it's not really surprising, right? So almost half the people really like the visibility and control that the API provides, and then 25%. So I like the way that the responses have been sort of divided up. That makes a lot of sense to me just based on conversations I've had with customers. Very cool. Thank you for answering those questions. The learning from our customers is hugely important to us because 90%, 95% of what we build at AWS actually comes from customers. And so if there's something that our customers like that they're gravitating towards, we're always looking for ways to improve what we already have or build something new and innovate. So thank you. Okay, so let's move on here to myth number 3. Data residency means better security. And so what do I mean by data residency? I hear this a lot. I mentioned I happen to be in Germany today, and I hear this a lot in Germany, is keeping your data in a specific location and not allowing it to move from a specific location leads to better security for that data. This is the myth that I hear very, very often, particularly in Europe. And so why do I say it's a myth? Well, remember, I talked about this in depth earlier. There's 5 ways that organizations get initially compromised. Okay, keeping your data physically located in one location does not mitigate any of those risks at all. And so from a data protection perspective, from a security perspective, data residency actually doesn't provide any security over and above having data distributed. Okay. There's a few more reasons why I say this. So for instance, most attacks happen across a network, right? It's very rare. Maybe that insider threat that I talked about, and most of the insider threat studies I've seen is that malicious insider, it represents like less than 1% of your workforce, right? And so most threats are not like physically done by somebody sitting at a keyboard inside of a data center. They're actually done across a network. And so again, whether the data is geographically distributed or located in one particular location doesn't impact that type of attack. And I mentioned, sometimes there's administrators that make mistakes that lead to misconfigurations and so on. Okay, again, having data resident in one location isn't super helpful when it comes to mitigating that type of threat. Okay, there's lots of different types of technologies that you can use inside the cloud to help mitigate the threats that you're worried about that data residency don't mitigate, or I should say doesn't mitigate. Encryption is your best friend, right? If you're really worried about threats inside the cloud, you're worried about insider threat, you're worried about legal threats to your data, all sorts of different threats that organizations are worried about. Encryption is your best safeguard. So encryption and of course, really good key management, because the whole point of encryption is to reduce the threat surface, the attack surface from all of your data. Once you encrypt the data, it moves the attack surface down to just the keys, because now the data has been encrypted with the keys. So protecting those keys at rest and during encryption, decryption functions is super important. Tokenization has been used, for instance, for PCI compliance and other scenarios for a long, long time. That's also available. You can do that in the cloud. Data decomposition. This one I hear a lot about. Customers are worried that, for instance, law enforcement could come into some provider and seize a server and take it back and do forensics on it. And because it could have multiple tenants on that server, then other people's data is at risk as well. And in a modern data center with modern storage, it's simply, that's just not the case, right? So if you have a file and that file is larger than 64K, that file will get chunked up, right, sharded into 64K chunks. And it'll actually get stored, each chunk with an individual encryption key and sprayed inside of a data center with tens of thousands of servers. So the old-fashioned notion that someone's going to come inside the data center and steal or take a server or a drive doesn't get them anywhere when you're faced with that type of data decomposition and encryption infrastructure. So there's lots of different mitigations to that type of threat here, and including deception technology. I'm a big fan of deception tech. This can be a very powerful cornerstone of your cybersecurity strategy. Having, honey keys and honey credentials and having, fake infrastructure implemented that no one should ever touch, can be a very powerful mitigation to help you understand if there's bad guys or malicious insiders in your infrastructure. So you've got lots of options here. All right. So that was the myth around, data residency providing better security. It simply doesn't. There might be valid reasons for keeping data resident, but security is not one of them. And so if you're having those conversations inside your organization about the requirement to keep data resident somewhere, I can understand if there's some law or some regulation that you have to observe. But if this is about conforming to an internal security standard, you should revisit that through the lens of those 5 ways that organizations get initially compromised. And I think you'll quickly realize that data residency is not the answer and is not a mitigation to those particular attack vectors. All right, so let's shift gears now and move away from myths, and let's talk about some of the opportunities. The first one being higher levels of security assurance. So what do we mean by assurance? So I go around and I talk to lots of customers about security, about threats, about risk management, and I tell them how our services work and how different mitigations work to help address the threats and the risks that they're most worried about. And that's just my good word. In Amazon, we make a lot of claims about what our stuff does, but what a lot of customers are looking for, especially in the public sector and the commercial sector, is assurance that we do what we say we're doing, that we manage these services in a way that's responsible and it's consistent with industry standards, that we're actually going to meet their internal standards or exceed them. And although they trust us, um, when it comes to audit and boards of directors and their audit committees, and if you're in a regulated industry, you actually need proof. You need to build a chain of trust with the auditors and the regulators in your industry and your location. And so you need a trusted third party, like a professional audit firm, that will come in and make sure that we're doing what we say we're doing it, what we're doing and how we're doing it is exactly how we're doing it. And so you can see here, I've got a subset of different certifications and attestations that AWS has. There's like more than 60, so this is just a small subset. And some of these are global industry standards like ISO 27001, which is the international standard for information security programs. There's also ones like, for instance, the gold standard in the cloud industry is the SOC 2 Type 2. And the reason I say that's the gold standard is because it takes 6 months to get that certification. So imagine AWS has, over 165 services at this point. You can actually go up to that link that I have at the bottom there and find the page that actually shows you service by service which certifications and attestations we have for each one of those services. So these services are being audited 6 months at a time. Some of these other certifications and attestations you see there are being audited, during the same periods of time, different times. In order to do a 6-month audit, it's actually overlapping. By the time we finish one audit, before the report's even been published by the auditor, they're actually auditing for the next 6-month period. So this stuff is constantly being audited by Ernst & Young and other trusted third parties. And then you actually have the ability through CloudTrail, which I mentioned earlier, to do your own monitoring auditing in real time against whatever standard you choose to care about. And so imagine for the first time ever, you're actually able to do audit or monitoring in real time, so that in addition to these point in time certifications and attestations that are super important, you can also see exactly what's happening in your account with your resources and your data in your real time. And you can make changes if it strays out of your standard or the certification that you care about. Again, you can use something like Lambda or AWS config rules to pull it back in to what that standard should look like. Because after all, the infrastructure is just code. Okay, so the other thing is if you're trying to do this on-premise compliance and audit programs can be very time-consuming, complicated, and expensive. When you come into AWS, imagine you're getting that whole platform is already certified and already has the attestations that many organizations are looking for. Like when you go back to this list, you can see that very few organizations would spend the time and money and effort to get all of these different attestations and certifications. Very often, many organizations that I talk to, they need to get PCI or they need to get HIPAA. SOC 2 is a great to have and helps them many different ways, but it's expensive and it's time consuming. So with AWS, they can come into AWS and we've already got all of that for the platform that they're going to build on. So that they don't have to do that now in their own data centers because we've given that to them. They've delegated that responsibility to us. And that reduces how much of that compliance program they actually have to do. Now they just have to focus on their application they're building on top of, or their infrastructure they're building on top of AWS instead of the entire stack. So it reduces the amount of effort, time, and money it takes to do that type of compliance. All right, so it's time for another survey question, Jess. Wow. Wow, that's very interesting. Yeah, I noticed in the United States, everybody is interested in NIST, but that tends to be sort of a US government standard. And so outside of the United States with international audiences, I typically get more interest in ISO. So very interesting. And it's also interesting to see just how small SOC is, right? As I mentioned, the SOC 2 Type 2 contains, last time I looked, I think it was 143 controls or something like that, or 120. And it has, auditors' notes in there that can be very helpful as well. So that's really interesting. That is very interesting. Thank you for sharing. Okay, last part of the presentation here is on innovation. So this is a huge opportunity. I'll start this one off by just telling you a personal story. And so recently I moved from the United States. I lived in Seattle for almost 20 years. I moved to London with my family. So I've got my wife Brenda and my two kids that are two boys, 14 and 17 years old. And shortly after we moved to London from the US, we decided to go and do a walk, right? On a weekend, we thought, hey, let's go down and do some touristy things. Let's visit, the London Eye that you can see in the background of the picture that I took. Let's walk down by the Thames. Let's do some touristy stuff. And as we approached this call box that you can see in this picture, my 14-year-old yelled out, like, what's that? He pointed to the call box and he asked me, what is that? And I was like, I quickly thought, well, he grew up in the suburbs of Seattle, and there's probably not a whole lot of phone booths out in the suburbs because we're sort of in the mountains around Seattle, out on the east side, as they call it. And so I thought, yeah, he probably doesn't know. He's probably never seen a phone booth before. He's never seen a call box in London before because he just moved there for the first time. So I quickly explained the concept of a call box to him and what it's used for and so on. And in youthful exuberance, he said, "That's stupid. Who would use one of those?" And so I quickly thought to myself, I bought him a mobile phone way too early in his life. That was the first thing that went through my mind. But I was astounded. I was really astounded because the telephone was arguably the most important technological advancement in my parents' lifetime. Where I grew up in Northern Canada, the first, party phone system that they installed in Canada in our area was a huge thing for them. That meant that they didn't have to get, on horses or when they finally got cars and drive over to the neighbor's house that was 3 miles away. They could actually just go and pick up a phone and call them. So it was a huge technological advancement that was a game changer for them in that community. And despite it being the most important technological advancement in my parents' lifetime, my own children didn't even recognize it when they saw it. So this was startling to me. I did a little bit of research on the call box, and you can see some of the things I found out about it here. But essentially, the call box became obsolete in less than 100 years. And there's plenty of examples of different technologies out there that have become obsolete a lot faster. It seems to be that obsolescence is happening quicker and quicker and quicker as technology advances faster and faster and faster. So this is exactly what's happening in the cloud. In fact, if my children go into IT, if they pursue a career in information technology, I don't think they'll ever even see what a physical server looks like. You can see here that in AWS, the pace of innovation is absolutely astounding. the number of new services being released, the number of feature functionality enhancements to existing services are coming so fast that it's actually amazing. Take a look at the numbers here, like 1,430, 1,957. I mean, it's actually increasing instead of decreasing like you would expect it. And that's because at AWS at this point, Andy Jassy, our CEO, announced at reInvent in November that AWS has over 165 services now. And the reason why they're able to innovate so quickly is because they're using all of these as building blocks. That means that they don't have to re-implement, for instance, what you can see here as core services. They don't have to re-implement storage and compute and databases every time they build a system because they already have some of the best storage databases and compute available to them in the world to build on top of. So they're actually able to accelerate how fast they're building services using these services that you see here as a building block. And so you have exactly the same opportunity. You have the same building blocks that they have access to innovate in your own organization. It's absolutely astounding. So I'll give you an example. I keep mentioning serverless with Lambda. This is one of the reasons why I think my kids will never even know what a server looks like. Is because it's code as a service. You don't actually have to provision hardware, like order hardware from a vendor, wait weeks or months for it to show up to the shipping dock, unload it, rack it, stack it, power, cooling, networking. Now you can put an operating system on, you got to patch that. Now you can put on, .NET or Java, got to patch that. Now we got to the point that you can actually install your application and start using it for what you want. In AWS, you can actually do that in minutes with a credit card. You don't have to deploy hardware and operating systems and all this stuff because you only want to run code. You want to actually run an application that processes, transmits, and stores data. Well, this serverless stuff, you can do that and get rid of all of that stuff that we've been doing for the last 30 years because that was the only way to do it. Okay. Another example is AI and ML, right? So artificial intelligence, machine learning. This is a game changer. When I grew up, the only place that they had AI and ML was science fiction movies. Honestly, I'd go to see science fiction movies. I'd come out and say that was a great movie, and then I'd go back to my life that bears no resemblance to that at all. None of that technology even existed outside of science fiction. And today they finally taken it out of the labs in the universities, and they've literally democratized AI and ML. Whether you're an AI expert and you're looking for, to create your own frameworks, your own approaches to AI, we've got services at the bottom of the slide here for that. Or let's say you have data scientists that know all about ML and they're willing to use pre-trained models or whatever. We have, the middle layer of services for those folks. Or if you're just an organization that doesn't have a whole lot of AI ML experience, we've actually commoditized this stuff for you. And we have a whole range of services that allow you to take advantage of this stuff without any knowledge of AI and ML. This is a game changer. You can use this in a security context now and literally have, for instance, Guard Duty is a service that uses AI and ML to go through and look at logs from, DNS logs, VPC logs, the CloudTrail logs I keep talking about, and looking for indicators of compromise in that for you automatically. We've got to the point where now Alexa can read off alerts that Guard Duty finds. I mean, it's just like you've seen in science fiction all of these years. This is my favorite quote when it comes to innovation. The future is already here. It's just not evenly distributed. I mean, the future is here. And so I'm inviting you guys to join us in AWS, come and use these services. It's incredible. The pace of innovation that I'm seeing inside of AWS is just incredible. And all these services are sitting here waiting for you. IoT is another huge game changer. And there's not an industry anywhere that's not already using it. So please, I'm inviting you to come and look at the 165 plus services we have at this point and embrace them because there's so much stuff that you can do once you get rid of the old technical debt and the old way of doing things. This is truly a game changer for you. So I've written a blog on this innovation stuff and my family's journey down to the Thames. If you're interested in reading that, and I've actually I'm talking about a customer that I've talked to over the years about moving into the cloud and sort of their journey and their thought process that I think could be helpful to a lot of organizations. All right, so with that, it's time for our very last survey question.
Okay, so what do we have? Quite a spread here. 30%, like all of the above. So they are inspired by a lot of our different services that can help them. We have 24% for the core services, 26% for security and compliance, which Tim, you would probably like to hear, 11% for machine learning, and 8% for infrastructure.
Wow, that's very, very interesting. Thank you for sharing your thoughts with us in today's surveys. And also thank you for attending. I know we're out of time at this point, but I'm more than willing to answer questions for folks that are able to stick around an extra few minutes, but I completely understand if people have to leave because we only allotted an hour for the session. But thank you very much for attending today, and I hope it was a useful presentation for you. So with that, Enrico, do we have any outstanding questions that we should try to answer?
No really outstanding questions. There was a interesting comments before when we were talking about malware, and the comment was kind of, I'm assuming kind of joking and saying, you know, I'm feeling bad now downloading the webinar executable without too much thought.
Yeah.
Which is an interesting point, right? So I guess the question there could be, I mean, is there anything we can say about what is the or what could be defined as a sufficient level of awareness, control, or alerting when we operate online?
Right. So I mean it's a very broad question, right? It's about
Yeah.
risk management. So for me, you know, I've encountered this many times through my career. Is like I get invited to a meeting and then I'm expected to install some sort of third party meeting provider software or something, right? And it comes down to risk, right? And it's like, okay, so do I trust the source of the software? Because if I don't know who the source is, I'm not going to trust the software. That's been my mantra my entire career. If you don't trust the source, don't trust the software. The other thing is, do I have any controls on the system where I'm going to install it, like antivirus software? That I know a lot of people don't like antivirus software for many reasons, but the reality is most of these AV labs are processing, as I mentioned earlier, millions of threats every week. And so if you have it installed, it's going to be able to detect and block and perhaps even clean millions and millions of different threats that you encounter. If you don't have it installed, you're not protected from any of those. So although it doesn't protect you from all threats, it's only the threats that they know about, that's still millions and millions and millions of threats. And so for me, it really is, you know, do you trust the source of the software? Is it signed? You know, meaning that I can trust the people are who they say they are, the package is the original package that they provided, and the AV software is not picking it up as a threat. You know, that's sort of my basic level from a personal perspective, but everybody has their own appetite for risk and their own requirements about what mitigations they need in place. But a very good question. With that, I will thank everyone once again for attending. You know, thanks very much for taking out time out of your busy day. And I think we're going to do another webinar in a month or two again. So please keep a lookout for future webinars in our security series. And thank you very much.